Hello everyone. So in this video we are going to discuss a few NCERT questions from the chapter Electromagnetic Waves. Okay. So this is first question is question number 8.3. What physical quantity is the same for X-rays of wavelength 10 power minus 10 meter and the red light of wavelength 6800 angstrom and radio waves of wavelength 500 nanometer? Okay. Now see, electromagnetic waves, they have a property like all the electromagnetic waves. Okay. Whether it is X-rays, whether it is visible rays, whether it is gamma rays, all the electromagnetic waves, they travel with a velocity of 3 into 10 power 8 meter per second in free space. Okay. In free space or vacuum. So this property is same. Okay. This speed is equal to 3 into 10 power 8 meter per second in free space. This property is same for all waves in the electromagnetic spectrum. Okay. So what physical quantity it is asked? The physical quantity is speed of the wave. Okay. Next is question number 8.4. A plane electromagnetic wave travels in vacuum along z direction. What can you say about the directions of its electric and magnetic field vectors? Okay. Now see, electromagnetic waves, they have a property like suppose this is your z axis. Okay. This is y axis and this is x axis. Okay. Now the property is like if the wave is propagating along z axis, then the direction of propagation of electric field or direction of oscillation of electric field, direction of oscillation of magnetic field, and this direction of wave propagation, that is along z-axis, all these three quantities will be mutually perpendicular. Now in this question it is given that the wave is propagating along z-axis, z direction. Okay, so that means the electric field and magnetic field, they must oscillate along x-axis and y-axis. So they must oscillate in this xy plane. Okay, in this xy plane. So the answer is the electromagnetic wave, it is traveling along z direction. So electric field and magnetic field are in xy plane. Okay. If the frequency of the wave is 30 megahertz, what is its wavelength? Okay. Now see, wavelength, it is related to frequency by the relation lambda is equal to velocity divided by frequency. Okay. Now velocity of electromagnetic wave, it is a constant and it is equal to 3 into 10 power 8 meter per second. Okay. And frequency here it is given as 30 megahertz. Okay. 30 megahertz means 30 into 10 power 6 hertz. Okay. 30 into 10 power 6 hertz. Now this can be written as 3 into 10 power 7. Okay, this is 10 power 7. So this 3 and 3 gets cancelled. So 10 power 7 and 10 power 8. So that is equal to 10 meter. So the wavelength will be 10 meter. Okay. Now next question. A radio can tune into any station in 7.5 megahertz to 12 megahertz band. What is the corresponding wavelength band? Okay. Frequency band is given. Wavelength band is asked. So again we have the relation lambda is equal to velocity divided by frequency. Okay. Now the frequency band is from 7.5 megahertz to 12 megahertz. Okay. So frequency nu 1, it is equal to 7.5 into megahertz means 10 power 6 hertz. Okay. And frequency 2 is 12 megahertz. So 12 into 10 power 6 hertz. Okay. 6 hertz. So corresponding to these two frequencies, we can calculate lambda 1 as velocity is 3 into lambda 1 is 3. Now velocity of electromagnetic wave is 3 into 10 power 8 divided by this frequency 7.5 into 10 power 8. Okay. So if you divide this, this comes to be around 40 meter. Okay. Now similarly corresponding to this 12 into 10 power 6 hertz, the wavelength is 25 meter. So the corresponding wavelength band will be from 25 meter to 40 meter. Now next is this is question number 8.8. Okay, suppose that electric field amplitude of electromagnetic wave is E naught equal to 120 Newton per coulomb and its frequency is nu equal to 50 megahertz. Determine B naught, omega, K and lambda. Okay, see this ratio E naught by B naught. This ratio is constant and it is equal to velocity of light in free space or in the particular medium where the corresponding electric field and magnetic field values are given. Okay, now it is given here E naught and B naught. Nothing about the medium is given, so we have to assume that it is free space. So this V will be equal to C, that is velocity of light in free space. So that is 3 into 10 power 8 meter per second. Okay, acha. Now here electric field is given, E naught is given, B naught is asked. So B naught will be equal to E naught divided by V. So that is equal to 120 divided by 3 into 10 power 8. Okay, so this is equal to 3 4s. So this is 4 into 10 power minus 7. Okay, Tesla. 4 into 10 power minus 7 Tesla. Now next is omega. Omega is the angular frequency. Okay, frequency is already given. So what will be the angular frequency? Angular frequency omega, it is equal to twice pi times the frequency. Okay, frequency is 50 megahertz. 50 megahertz. So this is twice pi into 50 into 10 power 6. 50 into 10 power 6. Mega means 10 power 6. This is 3.14 into 10 power 8 per second. Okay, so this will be the angular frequency. Then it is asked the value of K. Okay, K is, now what is K? K, it is equal to omega by V, angular frequency by velocity. Okay, omega we have already calculated. Omega is 3.14 into 10 power 8. Okay, V is velocity of electromagnetic wave, so that is 3 into 10 power 8. 3 into 10 power 8. So if you simplify this, this will be 1.05 per meter. Okay, unit of K is per meter. Okay, Achha, this is K. Now lambda, wavelength is asked. Wavelength, lambda is equal to velocity divided by frequency. Frequency is given, velocity is known, 3 into 10 power 8 divided by frequency. Frequency is how much? 50 megahertz. So that is 50 into 10 power 6. Okay, so this is 6 meter. So wavelength is 6 meter. Okay, then it is asked find the expression for E and B. Okay, expression means you have to write the equation. Okay, so now if you assume that the wave is propagating along positive x-axis. Okay, so suppose this is your x-axis, this is y-axis and this is z-axis. Okay, so wave is propagating along x-axis. So we know that direction of wave propagation and direction of electric field. Suppose this is the direction of electric field and this is the direction of magnetic field. So oscillation of electric field, oscillation of electric field, oscillation of magnetic field, and the direction of wave propagation. These three quantities are mutually perpendicular. Okay, so electric field we have taken to be along y-axis and the magnetic field is along z-axis. Wave is propagating along x-axis. So in that case, we will write the electric field E as E is equal to E naught sine kx minus omega t, kx minus omega t, and so into j cap, means if this is a vector quantity. See, electric field is directed along y-axis, so I have written j cap. Wave is propagating along x-axis, so this is kx minus omega t, positive x-axis. Okay, and this is E naught. E is equal to E naught sine kx minus omega t. Now we have already known the value of E naught. E naught is 120 Newton per Coulomb. So this electric field can be written as E is equal to 120 sine, okay, K we have already calculated 1.05, okay, X minus omega we have already calculated 3.14 into 10 power 8, okay, into T J cap. Okay, so this will be the equation for electric field. Okay, now similarly for magnetic field we can write the equation as B is equal to B naught sine kx minus omega t. Okay, kx minus omega t because wave is propagating along positive x-axis, and magnetic field it is along z-axis, so this will be k cap. Okay, now again we can similarly substitute the value of this B naught, k and omega to get the expression for B. Okay, so this is how we can write the expression for E and B. This is question number 8.10. In a plane electromagnetic wave, electric field oscillates sinusoidally at a frequency 2 into 10 power 10 hertz and amplitude 48 volt per meter. Okay, so this is the amplitude of electric field. What is the wavelength of the wave? Okay, wavelength. Now frequency is given. Frequency is 2 into 10 power 10 hertz. Okay, now it is an electromagnetic wave, so its velocity will be equal to c, that is equal to 3 into 10 power 8 meter per second. Okay, so frequency and velocity is known, so from that we can very easily calculate wavelength lambda. Lambda will be equal to velocity divided by frequency. So this is 3 into 10 power 8 divided by 2 into 10 power 10. 2 into 10 power 10. Okay, so this will be 1.5 into 10 power, and this will be how much? Minus 2 meter. Okay, 1.5 into 10 power minus 2 meter. So this will be the wavelength. Okay, then it is asked what is the amplitude of the oscillating magnetic field. Okay, now see E naught by B naught. This ratio is equal to the velocity of electromagnetic wave. Here it is equal to c, that is 3 into 10 power 8 meter per second. Okay, so now we have to find B naught. E naught is given. Amplitude of electric field, it is 48 volt per meter. So B naught, it will be equal to 48 divided by 3 into 10 power 8. 3 into 10 power 8. So this is equal to how much? 1.6 into 10 power minus 7 Tesla. Okay, so this is amplitude of the oscillating magnetic field. Now energy density in electric field, it is half epsilon naught E square. Half epsilon naught E square. And energy density in magnetic field, it is B square by twice mu naught. Okay, now we have to show that these two quantities are equal. Okay, Acha. Now we know that E by B, this is equal to c or v, that is velocity of light, and that is also equal to 1 by square root of mu naught epsilon naught. Okay, so this E square here, this E square, this can be replaced as E square. See here, from this I can write E square is equal to B square divided by mu naught epsilon naught. So if I substitute this E square in this equation becomes UE is equal to half epsilon naught. Now E square is this quantity, so B square divided by mu naught epsilon naught. Okay, so this epsilon naught gets cancelled. So this is equal to B square by twice mu naught. But what is this B square by twice mu naught? It is equal to this U, energy density in magnetic field. Energy density in magnetic field. So energy density in magnetic field, it is equal to energy density in electric field.